Now, in this part, we're going to take a look at the duration of the QRS complex. Okay, so when we say that we're doing a R to R, so remember that this is an R wave right here, and this is another R wave. Okay, so when we measure these, we are saying we're measuring an R to R, and that is telling us about rate. When we talk about the distance for a QRS complex, or the duration of a QRS complex, we're talking about from the beginning of where that QRS complex is to where it ends. Okay? So we're measuring this part. So we're going to measure this part here. So we're going to bring our calipers in, and we're going to go ahead and measure. And when I do that, I'm just about getting 2. So because it's not quite at 2, it's just about 1.5. So I can cut that and use the difference. So in that case, I would say that, this would be like a 0.06. Okay? Because remember, if it was 1 block, it'd be 0.04. If it was 2 blocks, it'd be 0.08. And here, this is sort of in the middle at 1.5, so that's why I got the 0.06 is where I'm putting that. Okay. Again, if I move my calipers a little bit, you saw that they were just moving just a hair. It could actually make it to be that 0.08. So let's see. And when we look at these, we want to make sure that they are consistent. And I'm coming back down here to the ones that I was just looking at. And you can see that from where I lined those up to what we're getting as a reading, they are accurate. So therefore, that is a consistent QRS duration for our first ECG. Now, what do you do with something that is just a little wide and bizarre like you see down below? Well, same type of deal. Okay, so I'll just put my calipers right there, but I'm going to bring in my pen, and I'm going to say that here is where the beginning of that QRS complex is. QRS, and this ends up right here is where the T wave's at. So as I have to look at this, I have to figure out somewhere between here and here where that is going to end. So here's the Q, that's no doubt. Here's the R, and then here comes the S wave. Now going to end about right here. Okay? So I'm going to say that this is a QRS, and then this actually starts to form part of the T. Okay? That's what my opinion is. So you may have somebody else who's going to want to measure that a little bit different, but I'm going to show you one little thing here. And that one little thing for what we're talking about is that when we measure this, if we take it to where we believe that it ends, okay, if that's where we believe that it ends, so there's 6 blocks. So this means that this QRS duration is 0.24. And what we know is that anything that is greater than 0.12 is either coming out of the ventricles or it's following abnormal pathways. So not that I'm trying to give you a shortcut, but a lot of times once you get beyond that 0.12, it's telling you from our standpoint, again, basic ECG interpretation, that this is coming out of the ventricles. Okay? So hopefully that helps you out. I didn't plot each one of these down, but that gives you that idea that, I could, if I measured it up here, the point is I need to be able to make that go the whole way. One thing to keep in mind, that it does not end here. Okay, it does start here, but it does not end there because that wave continues to go all the way down. Okay, so if you said that it would go here and these were consistent, that's pretty close to what you would have here. And absolutely, I would say that this is still a wide QRS complex. Again, it's greater than 0.12, so it's following those abnormal pathways or going into the ventricles. Now, we need to try to put some other information together. And one of those things is to actually look at rates, right? So when we look at the rate for these things, let me clear this out. So one of the things for rates that we want to take a look at, if you're looking at your atrial rate, if you want to count what your atrial rate is, that is counting your P waves, right? So your P waves, okay, that is representing the atria. So therefore, a P to P is the rate. If the QRS, or the R to R, is the ventricular rate. So however we end up measuring these, whichever one you're going to measure, is going to depend on a few things. So the first thing we would take a look at is to decide whether or not anything is regular or irregular. The first ECG you probably recognize from before, and that looks like something that is irregular. So as soon as something becomes irregular for us, that means that we cannot do an R to R or a P to P. And the reason we can't do that is because then we can't get a good indication as to whether or not that rate is accurate. It's not going to give us that accuracy. So we'll just make sure that if I'm doing a P to P here, that these are not, you can see that they're not falling in alignment, so therefore they are not regular. Okay? So what I'm going to do now is I'm going to take a 6-second strip. And my 6-second strip may have some marks on it. If not, we're going to figure this out. Okay, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So right off the bat, when I take a look at this, okay, all the way up to here, this is only 3 seconds. Okay, we would need a 6-second strip to be able to identify what the rates are. So let's see what this one is. So when I take a look at this, again, from here to here is 3 seconds. And from here to here is another 3 seconds. And when you add those together, it gives you a 6-second strip. That is when this stuff will work. Okay? So if we were doing a irregular rhythm, okay, we would have to count the number of complexes that are here. And those numbers of complexes would then be multiplied by 10. Okay, so let's just say that this is an irregular beat, and these are all irregular. Ironically, they're all regular, but okay. So we're going to say that here's 1, here's 2, here's 3. I take 3 times 10, gives me 30. Now, if it's regular, what you should do is measure your R to R. So this means we need to pull out our calipers. Okay, so if I move this to a good spot, okay, I can do this a couple of ways. Going from this QRS complex from here all the way to here. Okay? So here's 5, 10, 15, 20, 25, 30, 35, 40, and now I have what looks like 3 blocks. Okay? So I have 43 blocks between those. Based off of the speed of the paper, which is 25 millimeters per second, the paper is going across that stylus at that rate. That means, by the way, this is how we get each one of these little blocks representing a 0.04, and each one of these big blocks representing 0.20. When I know this, there are 1,500 small blocks going across the stylus in 1 minute. That means if I now divide this by 43, I now have a heart rate of rounding it to 35. Okay, so that difference here is that this is giving you the accuracy. Okay, this is much more accurate for what the electrical heart rate is, as opposed to counting in a 6-second strip. Because every time you count in a 6-second strip, because you're multiplying it by 10, you will end up finding out that it ends in a 0. This is the same thing that you will do for your atria. So let's find out about our atria here. So with this one, we can move this just a little bit. There we go. Okay. If I go here, I'm going to show you the other way of doing this. Okay, so I moved my calipers so that I could move my rate to some heavy lines and make life easier for me. So what I've done is I go from here to here. Okay? And when I go between these two, you will notice that these actually are pretty well split. So if I were to take 5 blocks, okay, so there's 5 here, and I divided that into 1,500, okay, so if I took 5 into 1,500, I would get 300. Okay, so that's all I did. So I know that if I have 5 blocks between the two rates that I'm trying, or the 2 points that I'm trying to count, if I take 5 into 1,500, it comes out to 300. If I have 10 blocks, again, same thing. 10 into 1,500, this becomes 150. I have 15. I have 15 into 1,500. This now comes out to 100. And you will notice that my atrial rate now, so my atrial rate is at 100. My ventricular rate is at 35. They don't match. They should, but they don't. And that's where we're going to take a look at what our definitions are going to help us with. By the way, just to help you out, let me move up here. Okay. So for rates, again, this would be 300, 150, 100, 75, and it goes 60, 50, and that's about as accurate as you're going to get. Okay. Again, they do come in here. Again, to kind of come out here and say, well, you know, Tim, they do end in 0 the same way that if I were counting those, so does it really make a difference? Again, keep in mind that a difference between a rate of 60 and a rate of a rate of 60 and a rate of 55 is the difference between bradycardia and normal. So in time, yes, those things should come into play, and you'll also find out that when you're applying these roles, it also makes a whole heck of a lot more sense when you know how to measure each part of this ECG. The last part of this is, yes, we now take all this information and we apply what we have learned from our dissection of the ECG and apply it to the definition. So that is how we interpret it. Again, there are some areas for error that it depends on where we measure things, but it really comes down to taking this information, putting it into the definition that best fits it, and that is how we come up with our ECG. Okay? So let's dive in, take a look at some more of the definitions.